reports and that are already formatted for A4 paper and can be exported into PDF, Excel, Word, or directly placed into AllPlan. And your project documentation is ready. Now you will see special feature in AllPlan, so-called sweep bars along the path. With AllPlan, you can reinforce everything you have modeled. So it is no problem to draw a reinforcement for this kind of wall element with different cross sections along its length or along its path. We just need to define the reinforcement in one cross section and choose paths along which the reinforcement should be placed. As you can see, reinforcing this kind of element takes seconds. Now we are going to talk about the other software, for the one for structural analysis and design. Our solution for this is software SCIA Engineer, very powerful tool for all kinds of structures. So let's see what the main features are. Of course, multi-material design, all types of advanced analysis, automatically generated engineering reports, and also BIM functionality. Concrete member design in SCIA Engineer combines the best of an integrated FEA solution and straightforward hand calculations. For reinforcement design, there are several options of doing it. If user is experienced engineer, he can do calculation with practical reinforcement or use section check. Both methods are based on entering the assumed or practical reinforcement first, and then reinforcement is checked. But if user is young engineer, he can do reinforcement design using basic and additional reinforcement. The reinforced concrete design is transparent. All code formulas are available in the report, showing original mathematical notation, intermediate numerical values, and final results. Also, this report can be in various languages. So let's see how it works in SCIA. What is the workflow there? First window you can see there is Project Manager, where you can choose what you want to do. Start new project or open existing one. When you start a project, of course, then you have to input general data and, most important, choose code and material. Then you are in main SCIA window, where all comments and tools are arranged within the interface. Here, of course, we can use line grid for inputting structure. We choose, of course, 1D or 2D members for modeling. We also need to define cross sections, and after that, we can input structural elements in 3D window. Here we can see columns. For modeling plates and walls, we use, of course, 2D members. Okay, so, and also upper floor is here. And after modeling simple structure, we need to define supports. So this is it. And next step is defining the load cases. After defining and applying all the load cases and automatically generated load combinations, then we can run the calculation. With the goal of high quality results, we need to adjust mesh setup, and when calculation is completed, the results appear in the model. Running the command results, we can see 3D displacements of the whole structure, internal forces for all the elements, and so on. And finally, we can show all these entries and results in engineering report. So this is it. We can arrange it how we want and place there all the information we want. Okay, so in this video, next one, we will see the BIM communication between AllPlan and SCIA. So this is an architectural model. In AllPlan, we can simply exclude all layers that do not relate to the main structure. After that, of course, the only concrete structure is left here. So we will run a direct link from AllPlan to export model to SCIA. We get an export message and the model is then imported into SCIA. There it is. And now you can move on with adjusting the model a little bit and analyzing it. So as I have already mentioned, we must adjust the model a little bit in order to continue working in SCIA properly. So we can use that we can do with the command BIM toolbox, which will do an alignment in nodes. After that, of course, we can define supports and we can define load cases. So combinations are made automatically. With load cases, you input, and then we can run the analysis, the calculation. Of course, again, we get the results which we have to evaluate. Okay, so then we can do the reinforcement design. We run that tool and choose values we want to see. For this example, it is provided reinforcement with area, and here we have an excellent feature, conversion for real bars. With this command, the reinforcement is converted to real 3D bars. Calculated and graphically displayed reinforcement now can be exported to AllPlan, where we can detail it further. In AllPlan, we can generate legends, we can also place schemas, modify special positions, add additional reinforcement, set labels, and all the rest detailing, reinforcement detailing, what we have already seen in earlier videos. Okay, so in next few slides, we are going to see a few customer references made with BIM. Okay, this is a cable-stayed bridge in Edinburgh. In upper right corner, you can see the 3D reinforcement model, of course, made in AllPlan. All bars are placed exact same way as it will be on construction site. So there's no any doubts for site workers. Longest tunnel in the world, Gotthard Tunnel in Switzerland, is also modeled and done with AllPlan engineering. This is Tamina Bridge in Switzerland, of course, also done with AllPlan. And for such complex structures, it's extremely important to exclude all unplanned problems on construction sites. So this is a huge advantage of BIM modeling. This Aviatica building in Prague is also done with BIM communication between AllPlan engineering and SCIA engineer. Okay, so please feel free to follow us on social media to get all the latest information regarding our softwares. In the end, I want to say thank you to our partners, Arhing company, and to Mr. Arber. Please feel free to contact us if you have any questions, and also them. You can also contact them, the Arhing company. Thank you everyone for your attention. Have a nice day and goodbye.